Here is today's problem. 1 over x plus 1 over the square root of 1 minus x squared equals 2 root 2. Our first move is to get the square root term alone on one side. We subtract 1 over x from both sides of the equation. The left side is now 1 over the square root of 1 minus x squared. The right side reads 2 root 2 minus 1 over x. Next, we combine that right side into a single fraction over x. 2 root 2 turns into 2 root 2x over x, so the top is 2 root 2x minus 1. With the square root standing alone, we square both sides of the equation. The left side becomes 1 over the quantity 1 minus x squared. The right side becomes 2 root 2x minus 1 squared all over x squared. Cross multiplying clears both denominators in a single step. So x squared equals 1 minus x squared times 2 root 2x minus 1 squared. Let us expand that squared bracket term by term. Squaring the 2 root 2x part gives 8x squared. The middle term is minus 4 root 2x, and the constant is plus 1. So the bracket equals 8x squared minus 4 root 2x plus 1. Now we distribute the 1 minus x squared across all three terms. Multiplying by 1 keeps 8x squared minus 4 root 2x plus 1. Multiplying by minus x squared adds 3 more terms to track. Those are minus 8x to the fourth, plus 4 root 2x cubed, and minus x squared. The x squared pieces combine, and 8 minus 1 leaves 7x squared. So the right side opens with minus 8x to the fourth plus 4 root 2x cubed. It closes with 7x squared, minus 4 root 2x, and plus 1. The left side is still just x squared, so we move it across and collect terms. 7x squared minus x squared leaves 6x squared behind. Multiplying everything by minus 1 then makes the leading term positive. It now reads 8x to the fourth minus 4 root 2x cubed minus 6x squared. Then comes plus 4 root 2x minus 1, with the whole side equal to 0. Those root 2 coefficients suggest a substitution, so we bring in a new letter. We let t equal root 2 times x, which means x equals t over root 2. Now we rewrite each term of the quartic in terms of t. 8x to the fourth is 8t to the fourth over 4, which is 2t to the fourth. 4 root 2x cubed simplifies cleanly to exactly 2t cubed. 6x squared becomes 3t squared, because x squared is t squared over 2. 4 root 2x becomes 4t, and the minus 1 stays put. The new equation opens with 2t to the fourth minus 2t cubed minus 3t squared. It ends with plus 4t minus 1, and the whole thing equals 0. Every coefficient is now an integer, so we can hunt for rational roots. The only possible candidates are plus or minus 1 and plus or minus 1/2. We try t equals 1 first, plugging it straight into the quartic. 2 minus 2 minus 3 plus 4 minus 1 comes out to exactly 0. So t equals 1 is a root, and t minus 1 divides the quartic evenly. Carrying out the division leaves the cubic 2t cubed minus 3t plus 1. There is no t squared term, and we test t equals 1 a second time. 2 minus 3 plus 1 is 0, so t equals 1 is a root again. Dividing once more, we are left with 2t squared plus 2t minus 1. So the quartic factors as t minus 1 squared times that last quadratic. The squared factor gives t equals 1, and the quadratic holds 2 more values. By the quadratic formula, t equals minus 2 plus or minus root 12 over 4. Root 12 is 2 root 3, so t is minus 1 plus or minus root 3 over 2. Now we convert every t value back into x, using x equals t over root 2. T equals 1 gives x equals 1 over root 2, which is root 2 over 2. The next value is t equals root 3 minus 1 over 2. That gives x equals root 3 minus 1 over 2 root 2. Rationalizing turns it into root 6 minus root 2 all over 4. The last value is t equals minus 1 minus root 3 over 2. Rationalizing gives x equals minus the quantity root 6 plus root 2 over 4. Because we squared the equation earlier, every candidate must face the original. We start with the candidate x equals root 2 over 2. 1 over x is 2 over root 2, and that simplifies to root 2. Squaring x gives 1/2, so 1 minus x squared is also 1/2. The square root of 1/2 is root 2 over 2, whose reciprocal is root 2. Root 2 plus root 2 makes 2 root 2, so this candidate checks out. Next up is x equals root 6 minus root 2 over 4. 1 over x is then 4 over the quantity root 6 minus root 2. Rationalizing gives root 6 plus root 2, because 6 minus 2 is 4, but root 6 alone is already bigger than root 2. So root 6 plus root is bigger than root 2 plus root 2, which is 2 root 2. The square root term is positive, so the full left side sits above 2 root 2. This candidate cannot work, and we cross it off the list. That leaves x equals minus the quantity root 6 plus root 2 over 4. Here 1 over x is minus 4 over the quantity root 6 plus root 2. Rationalizing that fraction gives root 2 minus root 6. For the root term, squaring x gives 8 plus 4 root 3 over 16. That fraction reduces to 2 plus root 3 over 4. So 1 minus x squared equals 2 minus root 3 over 4. The number root 3 minus 1 squared works out to 4 minus 2 root 3. And 4 minus 2 root 3 is exactly double 2 minus root 3. So 2 minus root 3 is the square of root 3 minus 1 cut in half. Its square root is therefore root 3 minus 1 divided by root 2. So the square root of 1 minus x squared is root 3 minus 1 over 2 root 2. Flipping that gives 2 root 2 over the quantity root 3 minus 1. We multiply top and bottom by root 3 plus 1, and the bottom becomes 2. That leaves root 2 times the quantity root 3 plus 1. Multiplying through, that expands to root 6 plus root 2, so the left side totals root 2 minus root 6 plus root 6 plus root 2. The root 6 terms cancel, and exactly 2 root 2 remains. This candidate satisfies the original equation perfectly, so the original equation has two real solutions. The first is x equals root 2 over 2, which is about 0.7071. The second is x equals minus the quantity root 6 plus root 2 over 4. As a decimal, that second one is about minus 0.9659. We can run both solutions through the equation using decimals. 2 root 2 itself is about 2.8284. For the first solution, each of the two terms about 1.4142. Those add to 2.8284 right on the target. For the second, 1 over x is about minus 1.0353. The square root term comes to about 3.8637. Together they give 2.8284, hitting the target again. That wraps up today's problem. Thank you so much for watching. If you enjoyed the video, a like and a subscribe are much appreciated. We will see you in the next one with another problem to solve.